IGCSE from 2024 June, and it's paper 1. And this is factorise fully 6y squared minus 5y minus 4. So this is basically a quadratic, but we have to times a by c, and we get minus 24. And then we need that something to times to minus 24, so it's going to be a minus and a plus, or a plus and a minus. It needs to add to minus 5. Okay, so we've got 1 and 24, that's too big a difference. 2 and 12, that's 10 difference. 3 and 8, that's the correct. So it's going to be minus 8 because it's a minus for the 5, and plus 3. Now let's rewrite this again. 6y squared minus 8y plus 3y minus 4. So what do 6y squared and 8y have in common? They have 2 and y, so let's put it outside. Then you times that by 3y, and you times that by 4 to get to that. And then that's just going to be plus 1, and then 3y minus 4. So the actual brackets are going to be 2y plus 1 and 3y minus 4. Marvellous. Right, express this as a fraction in its simplest form. So in order to do that, we have to get a lowest common denominator for 4x and 3x, or at least a common denominator. And we don't need to square the x or anything. We can just make that x, because x goes in. But 4 and 3, the lowest common denominator is 12. There isn't anything else. So to do this, 4x goes into 12x 3 times, so it's 3 times 2x plus 1, plus 3x goes into 12x 4 times, and so that's 4 times 7 minus 5x. And that will give us 6x plus 3 plus 28 minus 20x. And that is over 12x, and then that's 31 for the 3 and the 28, so that's 31, and 6x minus 20x is, I don't know, 14x, minus 14x. That's over 12x, and this is what is going to go down here. There you go. Now, number 13. Harmon has 2 bags of beads. Bag A, there are 3 white beads and 7 black beads. So we fill this in. I'll do this in another colour. So 3 out of 10 for the white and 7 out of 10 for the black. Then in the second bag, there are 5 white beads out of 9, because we had those 2 together on the bottom. 4 out of 9 for the black, 5 out of 9, 4 out of 9. You get the idea. Then work out the probability that Harmon takes 2 beads of the same colour. So we just go along there, white times white and black times black. So that's 3 over 10 times 5 over 9 plus 7 over 10 times 4 over 9. And that equals 15 over 90. Is that, do I get, takes 2 beads? Yeah, that's right, plus 28 over 90. 15 plus 28 is 43 over 90. By the way, you can use a calculator. Just a lot of this isn't that hard. I mean, in terms of having to think. 90. When I'm really tired, I would use a calculator. Right, combined savings of A and B are 15,435 dinars. Savings of B are 45% more than the savings of A. Then the savings of B are 3 over 2, so 1.5 times the savings of Chanda, or C. Work out the savings of C. So let's start by working out who gets what in terms of the proportions. So if we say that X is what Abel gets and what Bahara gets, so Abel gets X plus, and then B gets 1.45X. And then x plus that equals 15,435D. So that's 2.45x equals that much. Blah, 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 D. And now we can work out what x is by doing 1, 5, 435 divided by 2.45 equals, so x, or rather what Abel gets, so Abel gets 6,300, and then B gets whatever 15, we'll just times that by 1.45, and that means that B gets 9,135 even D. So that's those. So then C has 3.5 times 3/2 rather times the amount of savings of 3. So they're bigger. Savings of B are 3/2 times the savings of C. So that means that 9,135 equals 1.5 whatever y. Okay, so now to find out what y is, this is all backwards percentages, or backwards something rather. We do that over 1.5, and that equals, it's going to be just a bit less than what A got. So C equals 6090. I'm not very good at reading my calculator when I use it. 6090D. There we go. So that's that much. So it's all backwards. That was what that was about. Right. A function is defined as 3x plus 1 over x minus 2. State the function of x that cannot be included in any domain of the function f. You can't have 0 on the bottom. If you have 0 on the bottom, it means the whole thing doesn't work. So that means that x cannot equal 2. It can be bigger or smaller than 2, but it can't equal 2. Right, express the inverse function, f to the minus 1 of f of x. So what you do for this, even if it was an easy one, this one's a slightly more difficult one, is you go y equals 3x plus 1 over x minus 2. And you win when it's x equals whatever it is. So now that does not look like a 2, but you get the idea. So now we times it out. So y equals x minus bracket x minus 2, 3x plus 1. We times out this, so it's xy minus 2y equals 3x plus 1. Now we need to get all our x's on one side and all our y's on the other. So let's add 2y to both sides. Plus 2y. Let's take away the 3x from each side. So let's say it's xy minus 3x equals 2y plus 1. I'm just going to reorganise that because it looked a bit ugly. And then let's take the x out of these. Let's factorise this side, the xy minus 3x. So it's x bracket y minus 3. That's not very nicely done. Equals 2y plus 1. And then it's x equals 2y plus 1 over y minus 3. Now we're going to say f of the minus 1, and we're going to fill this in x form. So 2x plus 1 over y, or even over x minus 3. So it does look a little bit like it did in the first place. We just moved the y and the 3 and the 2. Right, one last question. There are 20 sweets in a box. 15 of the sweets are red, 5 of the sweets are yellow. Frank takes three sweets from the box. Work out the probability that Frank takes at least one sweet of each colour from the box. See, this is sort of this question. But it's not, I'm not sure. So it's that, isn't it? So we can just do this. 15 are red. No, let's just do red, 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 yellow, 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 red, yellow, red, yellow. There must be a better way to do this. Red, yellow. I think it's listing though, which I find harder than doing this. So 15 out of 20 are red. 5 out of 20 are... Is he putting them back? Take 3 sweets from the bag. Okay, I'm assuming that it changes every time, so it's 14 out of 19. 13 out of 19. And then that would be still 5 out of 19. And then that would be 5 out of, oh, that's 18 out of 18. So this one would be, there's been a red, there's been a thing, so it's 18, but there's going to be 14 of those left, because there's 4 of those, and then that would be 4 out of 18. Oh, this isn't too bad. 14 out of 19. And no, that's yellow, so that would be, yeah, that's 15 out of 19. It's 4 out of 19. Good lord, this is a mess. Then let's put 18 on the bottom. The thing is, they haven't said if they put them back or not. If they turn out to do that, then this is wrong. So we've gone yellow, we've got 15. We've had a red, so that's 14. We've had a yellow, so that's 4. We've had 2 yellows, so that's 15, and we've had that's 3. Right, work out the probability he takes at least 1 sweet of each colour. Oh, so it's just going to be 1 minus the chance of only getting 3 R's. And that's the P of that. And minus the P of 3 yellows. And that is going to be 15 over 20 times 14 over 19 times 13 over 18, which is the chance of him getting 3 R's, plus 5 over 20 times 4 over 19 times 3 over 18, because we know that that one and that one are the only ones where you get the same thing all the way through. So now we get, hang on 1 second, let's do this, is 15 over 20, which I do realise has a better, times 14 over 19 times, what's that, 13 over 18? It's going to be horrible, isn't it? Or maybe it's not. 13 over 18 equals, it is 91 over 228, that could be worse, plus, and then it's 5, oh, let's see, okay, equals, so it's 5 over 20 times 4 over 19 times 3 over 18. Right, let's see what we get with this. 1 over 114. And then we'll add on plus 91 over 228, which is almost the same number. That's 2 over 228. So it's 31 over 76. So that's 1 minus 31 over 76. So that's whatever that is. 45 over 76. And that's where we're stopping.